What you find is attackers just kind of work their way up the inverse pyramid of difficulty, and they're going to start with where you leave the windows open. And on supply chain, we've built this system that's largely just a way to kind of go through checks to make sure that the things we know about aren't present, but it doesn't really look for these sophisticated attacks. And so now you've got very sophisticated actors using very complicated and convoluted processes to get control of things that are integral to the supply chain, to insert very early in the development lifecycle and conquer as many things as possible.
Hi, this is Derrick, and you're listening to the a16z AI podcast, where we dig into all things artificial intelligence with our in-house team of experts, as well as the founders, engineers, and researchers working at the state of the art. In this episode, we're doing a deep dive into cybersecurity with Socket founder Feross Aboukhadijeh and a16z partner Joel De La Garza. Although the discussion hits on a range of topics, from buying patterns to when organizations might be required to use AI for security, we focus on how large language models can help secure software supply chains. Hopefully even from attacks like the recent a16z utils breach that put a lot of organizations on edge. Feross kicks off the discussion explaining why these types of attacks are still so effective. As a reminder, please note that the content here is for informational purposes only, should not be taken as legal, business, tax, or investment advice, or be used to evaluate any investment or security, and is not directed at any investors or potential investors in any a16z fund. For more details, please see a16z.com/disclosures.
The whole security industry is pretty focused on, and maybe almost to the point of obsession with, known vulnerabilities. And if you look at the types of supply chain attacks we're seeing, let's take a16z utils as the most recent example. You don't stop the next a16z utils. You don't stop the next backdoor with a CVE database. And so, I think that probably the biggest reason is just that our tools and our approaches don't even attempt to solve the problem. That's kind of what it comes down to, in my opinion.
Yeah, I think the classic saying for these sorts of things is that you don't pick the lock if the window's left open. And so what you find is attackers just kind of work their way up the pyramid of, or I guess the inverse pyramid of difficulty, and they're going to start with where you leave the windows open. And on supply chain, we've built this system that's largely just a way to kind of go through checks to make sure that the things we know about aren't present, but it doesn't really look for these sophisticated attacks. And so now you've got very sophisticated actors using very complicated and convoluted processes to get control of things that are integral to the supply chain, to insert very early in the development lifecycle and conquer as many things as possible.
No, so where are the locked doors? Have we locked up the more obvious doors at this point, like maybe the more traditional attack vectors, and supply chain is just like you said, where the door is open or where the window is open, whatever the analogy is. If
you look at the traditional solutions in the supply chain and broader third-party risk management market are relatively basic. I've run third-party risk assessment teams in the past, and really large ones, and you're always left with sort of like the only way you can really validate these things is if you hire a full-time group of people to go validate this one company and their product. And by the way, you have to do this for 15,000 suppliers, right? And so we're still very much in the early days of this, and a lot of the solutions just aren't really cutting the muster.
You referenced some of this, but we've had vulnerability scanning tools for seemingly forever. Like DevSecOps has been a topic for at least several years now. We've had potential problems to some of this for a long time. I guess my question is, where's the gap between what's promised with all of these previous attempts and solutions and then what's actually possible?
It's easy to look for your keys where the light is. And so that's kind of what the industry has been doing with this known vulnerability approach. It's relatively easy to determine if you're using open source code that has known problems. There are databases of these vulnerabilities that are collected and cataloged in the National Vulnerability Database, or NVD, for instance. And most of the vendors out there that try to help you determine whether your supply chain is secure are really just comparing the open source you're using to this database of packages. And I'm not trying to rag on this too much or to say that folks shouldn't be doing this, because this is a good thing. It's good that we don't use known vulnerable code. That's a great improvement.
We presume we shouldn't use known vulnerable code, right?
Yeah, it's more about what are the unknown vulnerabilities? What are the things that we don't know about yet? I think coming back to the a16z utils attack that happened a couple of weeks ago now, let's say early April kind of timeframe, what we saw there was a very sophisticated attack that happened over the course of 2 years, where very determined actors got access to a project very widely trusted, very widely used in pretty much all Linux distributions, and then became the legitimate maintainer of that project and got their attack code in. And so given enough time and energy, given state backing or given kind of this type of dedicated attacker, eventually they will get in. And the typical things that we rely on to tell us whether code is safe to use, like, again, known vulnerability scanners, aren't going to tell you whether that's happened or not. And other things that a lot of folks like to talk about, like code signing, that's not going to help here either, because this is the legitimate publisher of the code. So that's also kind of a false, and nerds love to talk about code signing. Let's just sign everything, right? Like, that'll solve the problem. It's really tough to solve this problem. It's difficult.
I don't think we're being demeaning in sort of talking about looking for known vulnerabilities. Like, I think those tools were actually great, and I think they did a lot for the ecosystem. And if you think of the way that things develop, it's always going to be crawl, walk, run, right? And those were the crawl. Those were really sort of like, hey, we know this stuff is bad. Let's just not use it. And that was like step 0. And, and we've gotten through step 0 now. And so what's happened is the attackers, the sophisticated attackers, used to just use the known bad things to get into these projects. Well, now we stopped doing that. So now they've gone to the next level, which is let's take over and look like we're taking legitimate people taking over legitimate projects and insert hidden back things into them. So now we're at walk, we're transitioning to run. We probably have to do it in weeks, not months, not years. But this is the way that these markets evolve.
At some level, is this an organizational problem? Like, in the sense of whose job is it to ensure that code and dependencies and components and everything are safe? Or is that like an impossible job at this point, realistically?
Let's be provocative, right? Like, why does the CISO role exist? It's one of the weird organizational and corporate anomalies that I think exists in my lifetime that I've always kind of struggled with understanding. And it's sort of like, we have these folks that are on the hook legally, right? They sign financial documents. They have liability if they're a public company. They are facing trial. We've seen several CISOs now coming up for trial for these things. But they don't actually own any of the things that cause these problems. And so you have these very weird accountability loops in the organization where the CISO is held accountable, but engineering has to fix it. And engineering also has to like ship features to help grow the business so the business doesn't contract. And so you have these competing priorities in the corporation where resources are constrained and you have to make choices. And so I think to some extent, these organizational politics, right? Like, there's the classic argument that you always end up shipping your org structure or your org chart. Like, this is it. This is shipping your org chart where security is bolted on at the last minute. There's someone who's accountable but doesn't own it and can't actually fix the problems. And so you get a lot of these kinds of situations.
Yeah, that's where we like to encourage people to think about this earlier in the process. I know shift left is a buzzword at this point, but like, it is actually true that it's like 10 times more expensive to fix problems once they've landed in the main branch of your repository than if you can kind of nudge the developer earlier on in the process. And there's so much low-hanging fruit in that territory. In my mind, like, we just haven't really even scratched the surface of what we can do to help developers make better choices. Obviously, telling them that a package is vulnerable is an easy thing to do, but what about telling them that it's unmaintained, or that the maintainer has no reputation? Or what about telling them that there's been some sketchy activity recently, or that it's not very popular and they should consider not using it? Or there's a lot of open, unresolved issues. I mean, there's like a million things you can really do there. And they're not even all necessarily security related. Some of that is just like quality, right? Is this quality code on which to build the product that we're building? And engineers can actually, they'll care about that because it's related to the quality of the product they're building. And that's something that even an engineer that doesn't care about security can get excited about. They don't want to be coming in and fixing bugs that are caused by this bad third-party code that they've built their whole feature or their whole product on top of, right?
It's scary when you think back to look at the studies where it shows like what percentage of, say, Docker Hub had severe vulnerabilities in it. And it's like, if you're not paying very close attention and you're grabbing components that solve your problem theoretically, but
yeah. And most companies just let any engineer pick any component they want. And it's I don't blame them, because like, your engineers will rebel if you don't let them do that. And if you tried to kind of sign off on every dependency, you'd go crazy with the number of dependencies these days, right? Yeah. You got like tens of thousands in the average application. So it's not even practical for a security team to gatekeep it. I used to work at a place that tried to gatekeep every dependency back in like 2012, 2013 time frame. I don't think you can do that anymore.
Well, yeah, and I think to that point is like developers get promoted for shipping features, right?
Mm-hmm.
Like they don't get promoted for fixing bugs, and it all comes back to incentives and the way we've built those structures.
Is it fair to? This was always my question about shifting left. Like when I was at VMware, we talked about it all the time within like the cloud native world. Is it fair to developers to at some point to say like, the buck might stop with them if they're writing the code, they're using the dependencies. But like when you talk about liability, or when you talk, like that, it starts to get pretty scary again, because you're supposed to be shipping features.
Well, I think organizations that have had, so where you've had organizations where there are technical resources in the engineering team who own things as they were a product and not just a bug fix, you see success. And I think Google, this is the funny thing, is actually when you deploy developers who are the most brilliant people in the organization, and you deploy developers to fix these problems, they actually do a really good job of fixing them, right? Like modern programming languages that have had security as a requirement are actually very secure. There's a whole category of products, right? Like we used to use static analysis to look for code problems that are largely gone. And like modern static analysis has just become linting, looking for spelling errors, looking for things that are pointed in the wrong direction, stuff like that. Essentially, we have solved a lot of these problems. It's just about creating incentive structures and assigning ownership to the people that actually can solve them.
Mm-hmm. Yeah. And you're making a good point about like, can the developer be really held liable for the dependencies that they use, or for the third-party risk that they're bringing in? I don't know what the right answer is there, because in some sense, they're the closest to the problem and they have probably the most knowledge because they are making the decision to bring that in. But also, if you think about what the point of open source is, the point of components, and reusability and abstraction and encapsulation, like what's the point of all these concepts? It's so that you can, as a developer, you can grab code and you don't need to understand what's inside. You don't need to be an expert in whatever that third-party code does. If you say, no, actually you are responsible for understanding and vetting the full contents of that third-party code, like you are kind of losing a little bit of what gives you the advantages with open source, which is like the whole point is, you can just come in and use it and it works and it's not your problem.
So we'll get to AI, but I want to ask one more question just on the supply chain attacks in general, which is, what do you think the role is of application architecture? Was it inherently a good thing to move to a microservices and containerized everything and all these very distributed dependencies, or was there an argument? I know there are arguments to be made, but is a realistic argument that says like, we should just go back to I don't know, annual releases and shipping stuff on CDs?
I'm curious what you think, Joel, but I was definitely part of the shift to, at least in open source, the shift to smaller dependencies and many, many more dependencies. I think it all started, the real acceleration in the number of dependencies started with NPM and the Node world. Before that, apps used to have maybe a dozen dependencies, maybe 20, 30, maybe 50. With Node apps, it's common to see 10,000 dependencies. Like that's normal. That's very normal. It's often 1,000 dependencies just to get Hello World to show up on the screen with a React app. Like, I'm not even kidding. Go and try setting up a new React website. You'll get to over 1,000 dependencies just to get the first Hello World. I think that part of that was coming from a good place of wanting to do things in the Unix philosophy. One package should do one thing and it should do that one thing well. And if you do that, then you can kind of get as much reusability as possible. If you look at what people did before, they would copy paste a lot of code, like in the Python ecosystem and earlier ecosystems. They would just copy paste things because there wasn't a very good package management system that allowed you to add a lot of dependencies without running into problems. NPM solved a lot of those problems, but that led to a world where it became costless to add dependencies to your project. There's literally no downside to adding from the developer's perspective. Right. There is a downside. We're talking about the downsides now, but there's no downside from their perspective. They just type an install command, 3 seconds later, the code is there. And so we're in this world now where you have, thousands of, maybe tens of thousands of individuals that you're trusting in your application. And a lot of those are literally individuals. They're not like a foundation, a nonprofit, something with governance. You're talking like a person with a GitHub repo, and that's who you're trusting. And so it's really that's the big shift. And I don't know how I feel about it because there are benefits to it, but it's led to all these security problems. So
NPM has been great. That whole new microservices and decomposed development model has been awesome at making sure that whatever method developers are using is the correct method. Because the problem before that was that people would roll their own methods of implementing things, right? And cryptography was always the one where it was like, you'd have a developer that's like, I'm going to roll my own crypto. And that was just like oh man, the ship is going to crash into the iceberg and we're all going to die, right? Because it wouldn't be crypto. It would be like encoding, and it would probably be ROT13, and it'd be very easy to reverse engineer, right? This new methodology actually means that people, when they implement these things, they're probably using an approved cryptographic method. It's probably implemented mostly correctly. It's not just doing encoding. They may be doing hashing right. So like, I think it's made a lot of things better, but it's just created a new attack surface, and it's created a new set of issues around actually managing the things that are going in there and making sure that you're validating that the correctness of these things is what should be there. And it's funny because Feross likes to talk in his speech about, in one of his talks, about how there is this NPM repo in China that's managed different than all the other NPM repos. And it's always problematic when it turns up. And like, I feel like everyone who's ever worked in an internet scale company knows about that repo because it's shown up in your production environment at one point or another because a developer has installed it. And so it's really just about sort of understanding that like the risks with these things, with technologies, like the risk never goes away. It shifts, it takes a new form. And often, like I would argue, things get more secure and things get better because people have to work a lot harder now to take over these things than they did in the past.
And I'm seeing a little bit of a shift back to bigger projects that incorporate more functionality, and a little bit of a shift away from this extreme micro package, extreme microservice approach. I think usually when these new things come out, people get overly excited and they're like, they kind of jump in with a little bit of a zealotry that's like, this is going to solve all the problems. And then, as you actually face reality, you kind of tone it down a little bit.
So let's get into AI and let's start just broadly. And when we say AI, I'll assume we mean generative AI, but correct me if I'm wrong, because that seems to be just like a game changing, for lack of a better term, UX and technology. How does AI factor into the picture when it comes to the supply chain? And maybe starting with like defensively, what does it mean for improving our defensive posture?
Yeah, I'll take a first swing at that one. I think that the interesting thing when you talk to security professionals and you talk to people who run security teams, their number one challenge for the last 5 to 10 years has always been people or resources. Like there's more work than I can do with the people I have. And by the way, the tools I'm buying create more work. And so like I buy these tools to fix these problems, and lo and behold, I'm hiring people to run those tools. And now I've got even more people and more need for resources, right? So it's always been the case that resources have been the constraint for most security teams. And my hope is, as these things start to play out, and it's still very early and we still don't have a lot of great examples of this stuff working and all the usual caveats, but the hope is that these Gen AI techniques can actually start to bring to bear resources to tackle a lot of the really tedious work. And you see with security, on the blue team, on the defender side, it's always the case that you have to be right 100% of the time. And for 100% correctness, you need almost near infinite resourcing and the ability to run these things like forever at scale. And that's always been the challenge. And the one time you forget to do something is the one time someone finds it and exploits you.
The way I like to think about it, it's like an intern level of intelligence, at least with the GPT-4 and kind of where the models are at now. You can kind of think of it as this sort of tireless, infinitely scalable intern that it's not performing at the level of a human security analyst, but you can kind of slot it in and scale it out. And it's still way cheaper than a human would cost to do. In an ideal world, you'd have humans reading every line of code, of third-party code that comes into the company and signing off on it. And even then you might miss something, but like that's sort of the gold standard. And you only see a very few a very small number of organizations that actually can pull that off. I think like Google and companies like that do treat all their third-party code as like something that they own. They'll even check it into their own kind of source control. But then you got the normal rest of the companies out there that are just sort of pulling in this code and using it and not looking at it first. And so the way we think about the Gen AI on the defensive side is that it's not as good as a human looking at the code, but it's something. And so what is our challenge? Our challenge is we want to scan all the open source code that exists out there. That is not something you can pay humans to do. That is not scalable at all. But with the right techniques, with the right pre-filtering stages, you can actually put a lot of that stuff through LLMs, and out the other side will pop a list of risky packages. And then that's a much smaller number that you can have humans take a look at. And so we're using it as a tool in that way, sort of like to find the needle in the haystack, like what is worth looking at. It's not perfect, but it can help cut down on the noise, and it can even make this problem tractable, which previously wasn't even tractable.
Yeah, and I would just add on that, and I think that's exactly right, is that the way you have to remember that the attackers and the defenders exist in the same ecosystem. They are in a dialogue with each other, right? As one makes a move, the other makes a move. And so what we've seen is that the signature-based approaches and the static analysis-based approaches to securing code doesn't work. And you actually do need to understand the code, because the attackers now are writing things that look very much like legitimate code. Even to most developers, they would have a hard time spotting it. And so it is really about having that level of resources to conduct that kind of analysis on a big corpus of work. And that's a lot of work.
How much of the solution here is the scanning and identification part? How much is actually, and especially with generative AI, how much of it is actually presenting it to someone in a way that's useful, that cuts through alert fatigue, that just points them in the direction of doing something in a way that, again, that they see it and they click and they know they need to act and not just ignore it? Or
yeah, we see both. I mean, we're using it in our product in both ways. The first is obviously identifying threats that our static analysis techniques don't cover. So in a browser, there's a million ways to generate a network request. It's not just using the fetch API or XHR requests. You can put a background image in a CSS using a CSS rule, and you can kind of sneakily make network requests that way. And so one of the nice things about an LLM is if you put that in front of an LLM, it's just going to say, yeah, that's a network request. You can't really fool it in the way that you could fool static analysis rules if you haven't really thought through all those cases. So it's kind of like a fallback, at least for us. It's sort of like a detection of last resort almost. So we use it for that. And then also the explanation side, totally. Yeah. Joel will probably know about more examples, but just, at our company, it's used to turn like what would be a machine generated alert into something that's like a couple paragraph explanation that a developer could read and understand. And that is very helpful when you're putting these messages in front of developers and asking them to actually act on them,
Yeah, absolutely. I mean, I think it augments on both sides. I think that as this becomes more reliable and as we get a hold of the hallucinations, right? Because one of the interesting things that's been happening is that if you run, and I'm sure you guys have experienced this, if you run code through there, it will make up vulnerabilities inside of the code. Like there was one time where I was looking at I used to maintain packages a long time ago, and I was looking at a repo I was maintaining, and it told me there was a race condition in a function. And I spent all this time and just realized that it had totally made it up. And so it is prone to that now, but I do think that it does really augment both sides of that coin.
Mm-hmm. Are hallucinations such a bad thing in that context? I mean, aside from some wasted time, would you rather have false positives than
I would have jumped out a window if I'd spent that. If that was my job still, I would have been very pissed. But yeah, now as a hobbyist, it's like, whatever. Yeah, I can stay up an extra 30 minutes.
It's different for every organization. I don't know. I think probably the good default for tools is to err on the side of missing things, but to be really high signal, because everyone's drowning in alerts. They're going to love your tool if every time you tell them something, it's real, but it doesn't have full coverage. You correct me if you disagree, Joel, but it depends on the use case, obviously. But
the problem is, I guess this could be a dissertation. A big part of the problem is you've got a very wide spectrum of buyers when it comes to the security buyer. Mm-hmm. You have buyers on one side that were themselves developers, are hyper technical, and just are some of the most amazing minds you'll ever meet. And then on the other side, you've got someone who was probably an accountant or an auditor and has pivoted into security and doesn't really understand the technical nature of what they're looking at. And so when the buyers, when the way that the vendors have responded to this kind of market is that they've generally had products that try to generate as much information as possible. And so you end up with alert fatigue, and you end up with, sophisticated teams will tell you that these products are useless because they generate too many alerts, and unsophisticated teams will say you have to buy this product because it finds everything, right? And so it just becomes this very schizophrenic market where you don't know how to land and how to interpret kind of what's happening. And I mean, again, it could be a dissertation, but this all comes back to we are not yet at a point where we have measurable, enforceable standards for what being secure means, and we do not have a functioning risk transfer mechanism in the form of insurance that lets us insure against breakdowns in that framework. Right?
Do you think that LLMs or some sort of AI model ultimately becomes a part, integrating those becomes part of what's, say, legally or otherwise
I think it gets to the point of I think some of this work NIST has been doing with CSF and NIST 853, the NIST standards are getting good where you can almost start to effectively measure an organization against a baseline. And I think that as we can use some of these automation techniques to measure the entirety of the organization against the baseline, we'll be able to get to a point where like with fire safety codes, like most companies don't have firefighters working for them. It's just weird that in security, we have these security professionals that come in and work because we don't have a building code that lets us know that we can safely inhabit the space. And if a fire does start, we can probably evacuate in enough time to not die. Like we don't have that level of maturity for information security, but that is where the market will eventually end. And that is where we will arrive as a mature industry. It may be 2 years because LLMs will power us to get there quicker, and it may be 20 because these are really hard problems.
I'm going to say LLMs, but I feel like it's too narrow of a framework. So maybe I'll just say as AI starts to play a larger role in threat detection and in security, who do you think ultimately interacts with those products or those models the most? Is it developers? Is it security teams, systems teams? Who owns that within an organization?
Well, I mean, if it's being used to filter down alerts and prioritize alerts, then you'll have the security team interacting with the outputs of that. And, it doesn't necessarily mean that they're reading like summarized text. It could just be that that's like going on behind the scenes. It's being used to kind of help prioritize what they see. If it's developers seeing it, then I think you're going to see the more typical kind of summarization or helping them understand like what the context is for what they're looking at. If you're trying to explain to a developer that code they've written here is vulnerable, before LLMs, the way that most of these products did that was with some hard-coded example that they just had in the documentation. But now you can just put the real code in there and show them the fix, and it's a million times better and more useful. So I see both interacting with it.
Right.
Yeah, I would say so as well. I think one of the coolest things I've seen recently is there is an AI coder that will develop an application for you, and it seems to work. I've seen an example of it working. And the coolest thing about it is that they actually developed unit tests as part of this. Mm-hmm. And they will show you the results at the end. And you're just looking at this thinking like, wow, security should just be one of these unit tests. And boom, it just seems like, I think this will give us the ability to make security a feature of these other parts of the product, right? And not necessarily for some of these things, a standalone feature, and it's our product in itself.
Right. Yeah, if you have unit tests getting written or suggested at least by LLMs, I'm actually really optimistic about that. There was a bug back in, I think, early 2010s where Dropbox for a few days would let anyone log in with any password into any account. Do you remember this?
Yes, I do.
Yeah, you could literally type in any email address and then anything for the password, and it would just let you in. And there was no unit test that checked, let's try logging in with no password and seeing, or the wrong password and seeing, confirming that it doesn't work. And so after that happened and it was in the news, I was working at another company at the time, Cora, and I just added a unit test that's let's make sure that we test with the wrong password and make sure it doesn't work. I think a lot of teams did that right after that incident. They're like, oh, do we have a unit test for that? So I think having the tools just suggest that is a great
well, and
idea.
this is the funniest thing. We've all worked at different tech companies, but we've all made the same mistakes. Right? Mm-hmm. It's the password unit test. It's the, hey, let's redact password prompts when we log them to system logs or something like this. There's just this class of mistakes that we tend to make. And so I think to the extent that we standardize and automate this stuff, the world gets better.
Maybe it's a question of how good AI can actually get and how much it can actually improve the status quo. Because if we get to a point where, say, integrating and utilizing a model would be significantly better, and it seems like a lot of ways it is. When you look at negligence in any sense, it's did you do the baseline thing? And if this isn't part of it would be better to use AI than to use a human. Maybe that's a place where we finally say, okay, that's not a human job anymore. We can throw a machine at it.
Well, now at least with the open source example, it's not are we going to have a human do it or are we going to have an AI do it? It's, are we going to have anything look at this code at all? And so, if your alternative is nothing or an AI, and the AI is affordable and not going to break the bank, then I do think you're going to get asked that question, well, why didn't you use the AI to at least find the risks in the code?
It can help take gross negligence off the table. Mm-hmm. You still may be negligent, but you're not grossly negligent.
So how much do you think it actually can improve the status quo? The XZ vulnerability, right? I mean, that was discovered by a guy. I mean, not just a guy. He's an accomplished guy, right? But he noticed a small latency issue, right? And then investigated to the bottom of it. Can we get a model that eventually that goes to that level of detail, or can you prompt your way to secure code at some point?
That's an interesting one because that was a 2-year effort that was probably state backed. It was, we don't know for sure, but probably. And, I don't know if the LLMs today could have caught that. It was really, really quite something. But the truth is that like what we see, at least at Socket every day, is that the bar is so low. It's not like you're not dealing with a 2-year state-backed kind of an attack. You're dealing with somebody, they added 5 lines of code to the bottom of one of the files of your open source project that you're using, and it just steals your environment variables and sends them off to the attacker. And it's right there. And if anyone had looked, they would have seen it. It was like right there in the file, and literally no one looked, right? And so, and it's not just that your company didn't look, it's that like no one in any company looked, right? That's the kind of thing that we see hundreds of per week coming through the feeds. It's not to say that the XZ utils aren't important, but like they are. Obviously, that that's a huge, and that's an open problem for like how we can do better as a community to detect that. But the bar is just really, really low today for what people are getting away with, because no one's literally looking. People have this mistaken assumption that open source is just, oh, it's open source, so it's safe. Oh, I didn't write that code. I wrote the app code and I just used this dependency, so it's not my problem. But it is your problem at the end of the day. It's going to run in the same process as the rest of your app, and it's going to ship into prod. It's going to affect all your users. So it is your problem.
I might be shooting for the moon. I guess that's what I should be shooting for, like the low hanging fruit.
Yeah, again, it's crawl, walk, run, right? And like that vulnerability. I mean, usually when you look at like a lot of the stuff that Socket finds, you'll look at it, you'll kind of get it. You'll be like, oh yeah, I see what this is. Oh, that makes. But these were very well designed, very well hidden. Like I think these are just, and I think that this is the shape of what the future looks like. And to your point, like as these generative AI techniques evolve, like I think this will give us the ability as an optimist to take a lot of these problems off the table, just because we'll have a thing we can task to go review all this stuff, validate it, and develop use cases for it. Like just to do the grunt work that like maybe you don't have an Uber nerd working at your company that'll notice a millisecond or two off of a transaction.
All right, so let me ask for us, from a vendor point of view, how do you go about integrating generative AI or LLMs into your product? Is it good enough to call out to say someone else's API, or are you actually like training models internally? Because I'm curious, as more and more models are available, open or not, how companies go about actually integrating them.
Yeah. So when we started at Socket, we had in mind this type of security-minded developer. We thought that kind of we could generate these alerts that are based around the capabilities of a package. So say that a package uses the network and it didn't before, but suddenly this new version needs to start sending data out to the network. Think about like how a smartphone app works. You know, when you install a new update and it suddenly needs your camera or your contacts or your microphone, it doesn't just get to use those permissions. You have to approve them. It has to ask. Unfortunately, that's not how open source upgrades work. They can just add in that code and suddenly they're using these extra capabilities. There is no permission model that works like a smartphone app. And so our idea initially was, we'll just tell the developer and the security team whenever the permissions change, and also whenever they're bringing a new package, kind of what those permissions are. And that, in our mind, with all the supply chain attacks that we were looking at, that would have caught like 95% of the stuff we were looking at. It was because it was all this stuff where, what does an attacker do when they take over the package? They want to steal your environment variables. They want to steal your files. They want to ransom you. They want to delete your files or something like that. It stands out, right? So that's where we started. But then we kind of quickly encountered like teams where they just said, look, like we don't have the capabilities or the sophistication to be able to actually interpret that level of alert. And so, you know, while there are teams out there that we happily give that information to and they happily consume it and like it and use it, there are many more teams that just want to be told, is this package safe or not? Like, tell me if it's bad or not, and just intervene in the case that it's bad, and otherwise get out of my way. We were in the process of actually building out some AI, non-LLM based, that would have taken kind of a synthesis of all these different signals that we are looking at and determine whether something is safe or not. And then kind of right into our laps dropped like the ChatGPT API right at the right moment. And so we built a prototype using it, where we just kind of, when we identify these risk factors within a file, within a package, we'll ask the LLM to kind of do train of thought reasoning and explain like, what is it doing? What are the risks of this? And make a determination. And unfortunately, it actually was way too noisy and unusable with GPT 3.5. But then GPT 4 came out and we actually had something that we could ship to users. And so basically that was the key moment for us, was when we got GPT 4 access to the unreleased GPT 4. Actually, we were able to get access. And then we realized, oh my goodness, Like this thing is just popping out malicious packages, like 100 per week, right? And so we were like, this is incredible. This thing's working. And but now it's obviously evolved beyond that, and we're kind of looking at a whole bunch of approaches, other competitors besides OpenAI, as well as kind of our own models. And then there's also multiple levels. You don't want to just use everything. Shouldn't just use like the most expensive approach, because you'll just go bankrupt trying to scan like every open source package out there. There's just so much code. And so we end up with more of a hybrid approach where we'll like put it through kind of a dumber, smaller model, and then have almost like a consensus model where like if enough of the dumb models agree that this is risky, then we'll ask a smarter model. And there's like a lot that goes into it actually over time. It's quite cool.
Interesting. Did you think at this point, are you now like proactively thinking about the data that you're generating as potential training data for a model going forward? Like, I mean,
yeah, we have visibility into all the PRs that all of our customers and free users are opening. And so one of the things we're looking at is kind of what do developers and security teams do once we send an alert? Like, do they act on it? And we're going to be able to feed that in and kind of improve our models based off of that. But it's still early days for us. We're still building all this stuff out, and it's improving. Every week you get improvements with this stuff. So it's really exciting.
So I want to end on a negative note, I guess, which is like, how does it complicate things that attackers also have access to? I would say AI, but generative models seem particularly ripe for exploitation. So like, because it's beyond even phishing and social engineering, I'm wondering like how AI is opening up opportunities for attackers.
Luckily, the large model providers have done a great job of protecting everyone from the dangers of AI. So we don't have to worry about it. But in a theoretical world where we did, no, sorry.
What theoretical danger?
Being facetious. I think it's a little bit on the earlier point, right? It's the infinitely many monkeys with infinitely many typewriters will write Shakespeare eventually. So I think we can match them. I do think that, a lot of the attackers, they do have cost constraints. And they do have resource constraints that a lot of the blue teams don't have. And generally, the adage has always been that the red team always wins. But I do think that with this generative AI wave, and if we do believe that we can do meaningful agentic type products that will at least be the level of an intern, perhaps even a level one analyst would be great. I think that if you can deploy 10,000 of those and give them an infinite amount of time, that things will get better. Like I do actually see a path here for things to get markedly better, even though the adversaries have access to these tools.
Security is exciting because it is this adversarial field, unlike, architecture, where you just kind of build a bridge and the rules of gravity don't change. The rules of gravity are what they are, and you just, as long as the bridge stands up in the model, then you're fine. Like security doesn't work like that at all, right? That's what keeps it fun and exciting for all of us and keeps us all employed. But we'll figure it out. It takes time for society to catch up to technology and to develop like an immune response to these things.
It's really frustrating because like we always go on these doomer scenarios about like, oh, well, you can manufacture synthetic information that'll convince people that would otherwise not be convinced. But it's just like, we don't have these tools and people already believe all sorts of insane things, right? Like there's literally flat earth groups that like watch the eclipse and are now like working online to come up with a reason for why things aren't round, right? I just think that there is this gullibility in the human condition. And whether or not it's disinformation or Gen AI or whatever, like that gullibility will always be there. And I just think that this is part of our existence, and we'll get better at it. Obviously, our systems shouldn't just let anyone in. But again, not everything needs to be Fort Knox. Like I think we'll find the right balance, and like this is really cool stuff. I don't share the negativity, and I should, because I'm a security person.
And that is all for this episode. If you hadn't thought a lot about the nexus of LLMs and software supply chains, hopefully you have a better understanding of what's happening and where that space is headed. And as always, if you enjoyed the episode, please do subscribe, rate us, and tell your friends and colleagues about the show. Mandated norm.